Dear guests, welcome to another interesting talk here at the Technical Forum at Hydrogen Fuel Cells Europe at the Hannover Messe 2023. We have had a lot of interesting talks, and the next one is not going to be any different, because we will be talking about single component polyurethane gaskets for hydrogen and fuel cells. What are the advantages and what are the limitations? Here on stage we will have from CeraCon the Managing Director. Please give a warm applause to Dr. Frank Kukla.
So thank you very much for the kind introduction and the invitation to talk here to you at the Technical Forum here at Hannover Messe. So now we are talking about a very special niche. It's about sealings for hydrogen fuel cells with a single component polyurethane foam. So just an introduction who we are at CeraCon and what I'm talking about. So we have two business units, and first of all I will have some words about, on the right-hand side, the thermal systems we produce. So these are machines, automatic machines for heating, and they are heating up to maximum of 200 degrees C for curing of resins and glues and potting materials for the electronic industry. So they are always part of an automated line, and they are curing these materials. And of special interest here, of course, is the drying of printed pastes of bipolar plates of the fuel cells. These pastes often contain flammable liquids, and therefore our thermal systems are built according to the European paint dryer norm, the EN 1539, so to avoid any flammable liquids inside the oven and avoid any explosion. So this is one of our products we produce, but now we have a closer look to the sealing system division we have. This is on the left-hand side. So just a short introduction, what are the current processes for foamed liquid seals on the market? So there are three main technologies on the market. On the left-hand side, you can see the classical two-component process. So you have a mixing head where polyol and isocyanate are put together in the mixing head, and then you dispense this liquid onto your parts of the fuel cell, for example. And then a chemical reaction starts, and the foam is building up, and the curing reaction is also in one step for curing the material at room temperature. The second one on the right-hand side, this is a foamed hot melt. This means you have a material which is molten at 80 degrees C to a liquid, and then you mix it under high pressure with nitrogen to generate foam. This foam is then applied to the parts, and afterwards you have to cure this material under humidity and heat. So a typical curing is done at 90% humidity and 50 degrees C for a few minutes. Our technology, you can see in the middle, this is a single component foam, so only one material for the user, but it is all processed at room temperature. So there's no heating or no special temperature control. It's independent of the temperature of parts. You just apply the foam directly on your parts, and the foam is made only with compressed air. So this single component material is mixed with compressed air, and if you apply it, then immediately the foam is visible like here, and then you have to cure it under heat. So typical conditions for the curing are 5 minutes at 80 degrees C, and after these 5 minutes the material is completely cured. So this is the short introduction to the technology, but now the bad news first. Foamed polyurethanes cannot be used as a seal for hydrogen. And this is independent of single or two-component materials or any other foamed polyurethane. Because of the cell structure of the foam, the small molecule hydrogen will always migrate through this foam. So this cannot be used for the hydrogen, but of course there are other applications we can solve with this material. Other limitations, as you can see here, it's not possible to use it inside the high temperature fuel cell, SOFC, so solid oxide fuel cells. It's not possible to get direct contact with acids. This is because of the chemistry of polyurethane. They are not suitable to use with acids, like you have it in some electrolyzing facilities. And there is an issue with leaching of ions into purified water until now with the polyurethane foam. So at every application you need this purified water. There will be some ions leaching out of the polyurethane. If you want to have a gas sealing, so also for hydrogen, you can use this material in an unfoamed state. So as a massive material, then it's like a very strong rubber, and then you can use it. So in the next step, from the limitations to the chances we have with our single component polyurethane foam, is of course inside the low temperature fuel cell. The as I said here, PEMFC, the polymer electrolyte membrane fuel cell, of course. There will be a solution for the ionization issue because we will change the formulation of the foam to get rid of this issue with ionization into purified water so that we also can use our material later on for ultra-pure water applications. And it's very suitable for all IP applications where you need a watertight sealing for any kind of housings, electronics, or outside the fuel cell, electric connectors, but we will see the applications later. From chances to advantages of this process, of course, as I told, is a physical foaming process. So therefore, there is no influence of the temperature of your part you apply the foam on, of whether it's winter or summer, hot or cold, whether it's humid or dry. This doesn't play any role for the process. It's a very reliable and stable process for production. The materials are all compliant, of course, to the EU regulations of chemistry. Also, it doesn't contain any substances of very high concern, and we are compliant to the RoHS restriction of hazardous substances. And the cured material can be thrown away as domestic waste, so it's no hazardous material. In addition, our materials do not contain any fluorinated compounds like PFOA, the perfluorooctanic acid, or any hazardous plasticizers, which is also very interesting and important for future applications. Now we come to the working range of this kind of sealings. On the right-hand side, you can see a cut-through applied bead. This is the half circle. And as you can see, we have a line at 20%. This means up from 20% on compression, we are watertight, and you can compress the sealing down to 70%. So this is the working range of the material. So 20% for water tightness is very low and very good, and this is because we have a closed cell structure. This means the foam consists of closed air bubbles without any connection to another. So this is a very important feature for watertight sealings. Lower here you can see a graph of the mounting forces. Of course, if you have a sealing which should be compressed, it's very important to know how high the mounting forces are because of distortion of your parts. And you can see we have a linear increase of the mounting forces up to the 70% compression, and from then on it goes exponentially. So between the 20 and the 70% it's linear, and what's interesting, this linearity is also in a very wide temperature range from -40 up to 100 degrees C. This is very special also for polyurethane foam, and this guarantees very constant compression force of this kind of material. If you use foamed sealing, it's of course a non-destructive dismantling of your part. So in comparison to a glued part, you have to destroy to open it again. So if you want to make any changes in your part or maintenance, you always use a foamed sealing for this kind of applications. And it's an established technology with a very wide range of applications in the automotive industry until now. From advantages now to the applications we have with this kind of materials. So there are three applications you can see here. On the left-hand side, this is now a serial production of complex housings. In this case, it's the lithium battery pack of a car. But this is just only an example of an application like this. This can also be used with very complex, small 3D housings and ceilings to get water out of your electronics. So in the middle, this is the air humidifier plates for polymer fuel cells. So this is a stack of plates for the air humidifier, and this foam is used here as a sealing for it. And on the right-hand side, you can see a sealing for electrical connectors. So, of course, with the fuel cell and also with the battery packs, you always need electrical connectors which are watertight and can also dismantle at any time. And here you can see the application on the right-hand side. So far, two applications we have. And now the features of the material itself, as we call it, CeraPUR, at a glance. So this picture is no fake. If you cut off the foam and put a drop of water on it, it will stay on the surface. This is the closed cell structure I talked. So it's no sponge. It will not suck the water into it. The drop of water will stay on the surface. So the main topics are it's single component, so very easy to use for production. The A and B component cannot be mixed up. You are independent from any mixing ratio of materials. It's single component. It's a physical foaming process. As I told you, it's very stable and independent of parts temperature or surrounding temperature. It's a thixotropic material, which means that you can apply it on very complex housing, 3D. You can even apply it on a vertical wall without running down of the liquid material. Then it's thermosetting. This means that after the application, you have a thermal process at 80 degrees C, and after only a few minutes, the material is fully cured, and you can immediately go to the next step inside your automatic production line. The material is watertight, starting at 20% compression. It is compliant to all the regulations from the EU, as I told you, the REACH, substance of very high concern, and IHS. It's domestic waste disposal is possible because it's not dangerous and not hazardous. And last but not least, an important point, according to current EU regulations, polyurethanes with more than 0.1% of diisocyanates are restricted to users who can demonstrate specially certified training. This is new, and now in this summer of the year 23, this will apply from the European Union, this new regulation. And this is not necessary if you use our material because we have 0.001 weight% of free diisocyanates. So there are no special regulations for this material. I think this is a very good feature for this future of our material, that you can use it also for many, many different applications. So the time is quite good, so thank you very much for your attention. I've now reached the end of my presentation. Would like to thank you for your attention, and would be pleased to welcome you on our booth number 24 and discuss interesting applications with you. Thank you.
Thank you.